So when we are discussing about garbage collection, so I want to put a diagram. Okay, I'm not good at that. Let me say this is memory. Okay, or maybe yeah, this is assume that this round one is a memory, and it may happen that when I create an object, or let me take up a new class. So when I create an object, say string msg equal to new string of msg. Okay. Now what really happens in the memory is that when I'm using new operator, memory gets allocated. Okay, and an object is created, and that is assigned to a variable called msg. And how that really works is that you know in the heap there are a couple of things in the memory. One is called heap and other one is called stack. Okay, now heap means is a free memory in the RAM. Then the applications use operating system uses some set of memory. I mean in the initial maybe it may use 500 or 1 GB memory, and if you have 3 or 4 GB RAM, then rest of the RAM is allocated to the running processes as need is there by the operating system. So if whatever is the memory allocated for my Java program, then within that particular thing, when you create an object when you use a new operator, when I use a new operator, what happens is that particular object will be created, and the variable there will be a variable in the Java program. A variable is created and assigned to that, but and referencing is added, okay, to that particular variable object. Is this clear? An object is created in the memory. When I say new, new string, so an object is created in the memory, and there will be a variable is created, and this you can call this as a there is a another thing called heap. Okay, the variable will be in the heap, and this variable will be referring to the newly created object. Okay, and the next one will be, suppose if I say if I am making string msg1 equal to msg, any guesses what can be there in the memory allocation? msg1. What will happen to the reference? This also will be referring to the same object. Sorry? Suji, you said something?
No, sir, no.
Okay. Okay. So what really happens is that MSG and MSG1 they refer to this, and then that's because you are referring to the same object. When I create another variable and then assign the old already existing object to this, so then what will happen is, there will not be, when I say string msg1 equal to msg, I can do this. When I am doing it, there are two variables referring to the same object. It just means that, okay? Is this clear?
Yes.
Okay. It may happen that there will be multiple references like this. Sorry. It may happen that some message, let's say message n, and it might be pointing to the same object, and also there will be a number of other objects. I mean, applications obviously will have so many objects created. If we're talking about Java. Now, unfortunately, the memory is limited, right? Suppose if I have 3 GB RAM and maybe our system is using 1 GB, and there are other applications. You may be streaming video, downloading something, then maybe chatting with in the browser, right? And listening to me in the training, right? So you will be doing so many things. So maybe that it may happen that your whatever Java program you are running, that has objects and it needs a suppose 100 MB of memory. But unfortunately, our system gave you only 25 MB RAM. Okay, so what really happens is that the moment you start creating objects and using them, then after some time what happens is that your old object will be unused, in the sense maybe you may be making msg equal to null. Okay, you can do that, you can nullify the object. Okay, or it may happen that I have some private method string message equal to something. Okay, the variable message, its scope is only test method, and the moment method execution is over, message is void, or like freeing up memory. Okay, so it will happen that many times you need to you may no longer need the object. So then what happens is, and next time again the program again needs some more objects. I create maybe I call this method, I create say suppose gc demo, and maybe I'll make this as a public method for now. Demo dot test method. I call this say suppose 2-3 times. What really happens is every time a variable called message is created whenever I call a test method. Okay, and the moment the method execution is done, this message variable will be gone, and then next time when I call again, one more variable will be created. One more variable called message will be created of type string. Is this clear? Yeah. So what I'll do is when the method call is done, if I keep calling like this, or maybe some other method which needs another variables. So in that case, once the memory such as allocated to the process is limited, what garbage collector will do is that it will we cannot control how garbage collector works, but we can understand what the behavior of the garbage collector. What it will try to do is, suppose message, and if that is pointing to, okay, garbage collector will, and the moment you are done with using this variable, so the reference to the object will be lost. The message variable and the object, the connection will be lost the moment you are done with your variable, but the object may be there in the memory. So what garbage collector will do is that it will try to look at, it will actually have some mapping. Sorry, it will have some mapping where it will have this is for what to say, the object name and the count. object. So message, and it will have, say suppose count. If the variable reference is gone, in that case it will become 0. Okay, and say suppose msg in this particular case, or ms, no, not really, I should not write like this. For object it may have some unique identifier. Say suppose I'll say object 1, and that will have references as 0. And say suppose message, for message object, msg object, I'll say number, maybe number 2, and how many references I have? 3, right? msg, msg1, msgn. So it will look at, it will have a mapping of object associations, and it will figure out, I mean, whenever garbage collector gets called, it will figure out what are the objects that are having 0 references, that are having no references. So it will figure out, okay, fine, okay, in this case the object number 1 has 0 references. Then what garbage collector will do is that it will actually try to remove this particular object. It will try to remove this object from the memory. So garbage collector is to collect the garbage, in the sense unused objects. You're done with it. Maybe you wanted to have a cool drink. You took a can from the shop and you're done, and you are throwing that into a bin, or you're throwing somewhere. Then someone need to clean it up, right? You're done with your work, but you need to clean it up. So garbage collector purpose is that to clean the memory. Whatever is the unused stuff is there, it has to remove it from the memory. So it is used for this purpose. And actually this is something that you do not have any control on. You do not have any control on the garbage collector.
So all the objects that are created should be nulled, Hari, like when they are done by explicitly?
Yeah, we need to actually see when the scope of that method execution goes, that will be happening automatically, or we should avoid what do you call creating too many objects. Okay, or reuse existing objects. When there is, it will show the count. When you run profiler, it will show what type of objects are how many. Okay, so, and also flow, which method is creating that objects and all. So what need to happen is that we should actually control, based on, we should try to avoid using duplicate, unnecessary variables. And what else we need to do? So such as if you look at the garbage collector, it is to clean up. It will figure out what, and it gets kicked in, you do not have any control for it. It is part of your JVM, and as your application is running, and as long as you don't need, your memory, you have a lot of memory, maybe garbage collector may not be called that often. But suppose I'm out of memory, in the sense my application is running fast, and then I am creating so many objects, and it looks like I don't have memory. Then system, your Java JVM may call the garbage collector to see if some memory can be freed up. But you cannot call but then still you cannot call garbage collector. But there is a call called system.gc. This is for garbage collector, but here you are more like, what do you call, you do not, it is more like a request rather than a command. See, when I say demo.test method, what happens? The test method gets executed. But when I call system.gc, actually garbage collector, it is like replacing a request for garbage collector. It may not be called immediately. It may be called after some time. Okay, it is more like a request, but you still have an option to call garbage collector if you want to. But this is a request. Please try to understand. This is more a request and not an order. Okay, but if you look at is an order demo.test method gets executed. Okay, so that's actually primary difference. Okay, and when you run basically when you're looking at application perspective like WebSphere and all, what people do is that if you think that your application is not scaling up well, meaning maybe when there are 100 users your application is crashing or it is very slow, or after 2 days the application is hanging, you'll have this kind of observations. So what people do is to avoid that kind of situations, or when such a situation happens, to figure it out, what they do is they run profilers. Okay, profilers will give you how many objects are created in that particular application. When application is running, you try to piggyback or link the application with a profiler, and profiler will actually try to understand, it will link with the JVM, and it will try to understand how many objects are created, who is creating these objects, like all that kind of thing. So it will give you primarily like how many type of objects are created, and how many objects are there, the count, and what is the size of each object, and how many of that kind of objects are there. So when you look at those the profiler study, you can figure out, okay, fine, this method, this particular class, this method is creating so many objects. Go back, look at your logic, and just, oh, this is some stupid statement is there, you don't need this, maybe, or you can optimize it in some other way. So developer has to work fixing that particular part, so that you can avoid garbage collection. The frequently, if suppose if you are running short of memory, and if garbage collector gets kicked in very often, your system or your Java application will become very slow, because most of the time your garbage collector is getting called, and that has to verify all the objects that are there in the JVM. So to avoid that, always the best practice is you have to make sure that what you really mean when you write some code. Don't leave anything unattended to. You create a variable, and then you don't. If your method is long running method, or your object is long running, and then you have references to a variable, then if you don't need any more, then make it null. Okay. So this is on the garbage collection front. So I think I try to give you a brief about what it is, but garbage collection is a very interesting and important aspect of application development, and this is available even with .NET. They have a similar framework. So that's about garbage collection. Any questions?
I understand.
Yeah. So this words, stack and queue are important. They're general terms across all the programming as well as real life. Queue stands for first in, first out, and stack stands for last in, first out.
First.
FIFO and LIFO you can call. Now when you're actually now the topic now is heap and stack in terms of Java. So what will happen is, when stack contains a variable references or your primitive database data types. Suppose when I call a method, within the main, I'm calling test method, right? And after maybe I write another method, one, or maybe count equal to say 10 or something. Some logic, more logic, and it may happen that I need to make this as an int. It may happen that I call this method test method 1 here. Okay. Now what is happening? When I'm calling, from main method, I'm calling test method, and test method is calling test method 1. Is the flow clear?
Yeah.
Okay, I'll remove this extra methods. Okay, so demo method, I'm calling demo method, and sorry, test method on this object. And within test method, if I press F3, it goes there. There is some logic, and then I'm calling test method 1. Now, how about the life of these variables? What will happen is that your application will have, say, suppose, look at this. Now here the example is given as methods, in first and second methods. Now when I call first method, so the within the stack, they will store, in the stack, they store that method and all the variables related to that method. Okay, and now then I call another method called second. Okay, so now see that, stack here, if this is the stack, this whatever set of these rectangles, first is there in the initially when you call the first method, only that is there in the stack. But then when you call the second method, what happens is second method memory, all the variables, everything will be of the second are pushed there into, and with a reference to the method, into the stack. Now when second method is executed, there will be references for only the second related methods. I will not have access to the first method variables. Whatever variables I declare in the first method, I may not have access to. Only second method related variables will be stored in the stack. Now when this second method execution is done, finally what happens is it goes back again, from the stack, the second will be removed because it's already used, and again, it will go back to first. I'm just trying to explain using this diagram. Okay, so there is an order, in the sense, first a method is called, say, suppose method first, second, and third. Then first, when you call the first method, only the first method will be there in the stack, and then when you call second, first on top of second, because from the first method you are calling second. And suppose if you call third, then on top of second there will be third method as well. So the moment third is done, it will be removed from the stack, and then control will be given back to second, because the reason is when say, suppose now let's look at only second and first. Second method has some variables, some logic. Okay, so when the second method execution is done, you need to pass the control back to first method, and whatever variables you have in the first method and their values and all, everything should be available, right? So just because you call another method from a first method, then if you remove all the variables, then your program will go for a toss. So to avoid that, they actually store everything in a memory called stack. It's just a name given to, because of the pattern associated with it, because last one that you put in the stack will be out first. So because of that, we call this as a stack. It is in an orderly fashion. It is in the order of first method, second method, whatever the method invocation is there, in that order the variables will be stored. Now if you talk about the heap is free memory. Heap is free memory, and there is no order in the way you can create objects there. It's just that in the available memory, system will create, JVM will create objects there. Okay, that is the difference between stack and heap. You can read more about this thing. It's a very interesting thing. Again, in terms of interviews, this is a useful thing, because I'm talking about garbage collection. I thought I'll specify this one as well. I'll discuss about this. Now you look at this. Heap is used to store new objects created by Java. Stack is used to store more primitive data types like int, double when they are declared locally. All the local variables are stored into heap. I'll give you this link. You can read this. But the primary difference is that, in case of stack, there is an order. In case of heap, there is nothing like that. They are in the free memory, and the variables, whatever is stored into stack, is based on the method invocations, method calls. One method calls another. So my first method, whatever is calling it, that will be down in the stack, and new method you are calling, that will be up in the stack. And once your new method invocation is done, the memory for that particular new method will be removed, and the old method will be restored to the to execute it. So that's about